Okay, and welcome to video on multiplication properties using exponents. So today what we're going to look at is how do we combine expressions that involve exponents and some of the properties that we can come up with for when we multiply these exponents together. So these are the standards we'll be covering using the structure of an expression and identifying ways to rewrite it, specifically looking at exponents, and it's all in preparation for being able to interpret parts of exponential functions and different real-world examples of that. So today we'll multiply monomials and simplify expressions that involve those monomials. So the first property that we have here is called the product of powers. And what the product of powers says is that when we multiply two powers that have the same base, we add their exponents together. So what would be helpful to know is what do these two things mean here, base and exponent? Well, in a power has two parts. So let's take an example. 3 to the 5th power. So powers have two parts, the 3 and the 5. The 3 is what we call the base. It's the number that's being multiplied in an exponent. And the 5 up here is the exponent part. What that tells me is how many times we're multiplying the base. So 3 to the 5th power, all that's saying is that we're taking the number 3 here, and we're multiplying it 5 times. So 3 times 3 times 3 times 3 times 3. So 3 to the 5th power means 3 multiplied by itself 5 times. So exponents are a way of writing repeated multiplication. Just like the first time you learned how to do multiplication, you learned it as repeated addition. Well, what we're doing now is we're taking that same idea, but now repeated multiplication uses exponents. So some examples of what happens if we have multiple exponents with the same base. So if I take b to the 3rd times b to the 5th power. So in each of these cases, my base is b. So base for each of these. So b to the 3rd times b to the 5th. And what that's literally telling me is that b to the 3rd powers, I'm taking the letter b and I'm multiplying it 3 times. B times b times b is b to the 3rd power. B to the 5th power is b multiplied 5 times, or 5. So now what happens if I combine those two together? Well, over here I have 3, and here I have 5. So if I want to rewrite this as a power, altogether I have how many b's? I have 1, 2, 3, and then 5. So 3 and 5, if I add those together, I have a total of 8 b's. And that's what this property is telling us, is that when I am multiplying powers, if I have the same base, I can add the exponents together to give me the total number of bases that I have. So if I had 3 bases, 3 b's here and 5 here, all together I have 3 plus 5, or 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The other one here, g to the 4th times g to the 6th. Okay. What that means is I have g 4 times, 3 and 4, and we're multiplying it times g 6 times. So how many do I have altogether? Well, here I've got my 4, here I've got my 6, so 4 and 6 gives me a total of 4 plus 6, or g to the 10th power. So the product of powers is just saying that when I have powers that have the same base, and that's the key part, is they have to be the same base. Okay? If I had b and c, I couldn't combine them. But because they both have the same base of b, or they both have the same base of g, I can combine them by adding the exponents together. So let's take a look at an example. So our to the 4th power times negative 12 times r to the 7th power. So we want to simplify this. So we're doing r to the 4th times negative 12 r to the 7th. Well, if I look at my two expressions here, I see that I've got two exponents that have the same base. I have the base of r and r. So what I can do is I can rewrite this expression using the associative property, or sorry, the commutative property. I can rearrange this because the order doesn't matter that I do multiplication in. Whether I do 3 times 5, that's the same thing as doing 5 times 3. So when I'm multiplying, I can rearrange the multiplication however I want to do that. So I can take this negative 12 out, and I can multiply r to the 4th times r to the 7th power. So that leaves me with negative 12. And what we just saw was that when I have the same base, r to the 4th times r to the 7th, I can add those powers together to give me the total number of r's that I have. So 4 plus 7 is a total of 11. So r to the 4th times negative 12 times r to the 7th power is negative 12 times r to the 11th power. Okay. Same thing here, 6cd to the 5th power times 5c to the 5th d squared. What I want to do is rewrite the expression so that my numbers are together and my bases, my like bases are together. So that's going to give me 6 times 5. So pull those numbers out. Then I've got c times d, or sorry, c times c to the 5th power. So I put my c's together. And then I'm going to put my d's together. d to the 5th times d squared. So 6 times 5 gives me 30. And c times c to the 5th. Now it looks like there's not a number here with this first c. But remember, anything, just like with coefficients, if there's not an exponent there, just understand that there's 1. I do have 1c. So if I took c times c to the 5th, that would be c and then 5 c's, right? 3, 4, 5, for a total of 1 and 5, or c to the 6th. So just be careful, even though there's not an exponent listed here, it's understood that there is a 1 there. And then I'm going to add d to the 5th and d squared, or multiply them together, so I add the exponent, so it's d to the 7th. So my final answer is 30 times c to the 6th, d to the 7th. All right, so it's your turn. Go ahead and simplify 5x squared times 4x to the 3rd. And you should have gotten an answer of 20x to the 5th. And you would get that by pulling out the numbers first, so multiply 5 times 4, and then x squared times x to the 3rd. So 5 times 4 would get you 20, and then the x's, because they have the same base, I can add the exponents together, so 2 plus 3 leaves me with 20x to the 5th power. All right, try another one. 3xy squared times negative 2x squared times y to the 3rd. And you should have gotten a solution, negative 6 x to the 3rd, y to the 5th. And again, all you'd want to do is pull out the numbers and multiply them together first. So we've got 3 times negative 2, and then combine the variables that have the same base. So I've got x times x squared, and then y squared times y to the 3rd. So 3 times negative 2 would make negative 6. X, I'm going to add together my exponents because I have the same base. So I've got x and x squared, which means I'm going to add together x to the 1st plus 2 more x's. And then y's, I'm going to add 2 plus 3. So I get negative 6 x to the 3rd, y to the 5th. All right, so that was our first rule for multiplication. Let's look at our second one, which says the power of a power is where we're going to multiply the exponents. And let's take a look at why this is the case. So if we go back to this idea that when I've got anything, a number to a power, this is the base, and this is the exponent. And remember, the base is telling me what I'm multiplying. The exponent is telling me the number of times that I'm multiplying it. So if I take b to the third to the fifth power, let's analyze exactly what this is talking about here. So for b to the third, technically that can be seen as a base. B to the third is being multiplied, and it's being multiplied 5 times. So let's rewrite b to the third to the fifth power as multiplication. So what type of multiplication is it? It would be b to the third, because that's my base, that's what's being multiplied, and I'm going to multiply it 5 times. So b to the third, a total of 5 times. Right, so if I take out this expression, b to the third to the fifth power, and just write it out with multiplication, it becomes b to the third times 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 b to the third. Well, what did we just see? Our last rule said that when we're multiplying with the same base, I can add the exponents. So b to the third 5 times would be b to the 3 plus 3 plus 3 plus 3 plus 3. Okay. Now, this could get tedious and take a long time when we start getting larger numbers. So instead of having to write out multiplication, or b to the third 5 times and then adding the exponents, well, this 3 plus 3 plus 3 plus 3 plus 3, as we all know, is repeated addition, which means I can write 3 being multiplied 5 times. So 3 times 5 gives me a total of 15. Okay. So let's look back at the relationship to what we just had here. Well, I was doing b to the third 5 times. So when I added b to the third, added the 3's together, that was the same thing as doing 3 times 5. Well, over here, there's a shortcut. Notice I have the 3 here and the 5 here. So what this rule is telling me is that when I have a power, like b to the third, and I raise it to another power, there's a shortcut. Instead of having to write it out 5 times and then adding the exponents, I can just simply multiply these two numbers together. B to the third is occurring 5 times, so I can do 3 times 5, which gives me 15. It's the same process as writing it out and then adding the exponents, but I can just multiply them together and get my new exponent. Let's take a look at the other one here just so you can kind of see what it means. So if I take g to the 6th and raise that to the 7th power, g to the 6th is my base. That's what's repeating. So I'm going to do g to the 6th 7 times. And you can see what I mean about this getting kind of tedious when the numbers start getting bigger. So if I write out g to the 6th 7 times, well then that's the same thing as adding 6 together 7 times. 3, 6, 7. Right? Or I could have just done 6 times 7 and gotten g to the 42nd power. Okay? So this is why we want to use this shortcut, because having to write out these powers and then add the exponents can start taking a while. So the shortcut is we can take these two numbers here when we're raising a power to another power. Okay? We take the power that's on the outside and we multiply these two numbers together. So 7 times 6 is g to the 42nd power. And so let's take a look at an example here. I've got 2 to the third raised to the third power and then raised to the second power. So what that tells me is that I've got my base is 2 to the third. It's being raised to the third power and then raised again to the second power. So I'm going to start with just this inside part here. 2 to the third raised to the third power. So what that means is I can take 2 to the third, and the rule that we just saw is that I can multiply these two together. So do 3 times 3. Well, 3 times 3 is 9. So that 2 to the third power becomes 2 to the ninth. Then I want to raise that to the second power. And again, our rule tells us is that I can take 2 to the ninth and multiply the 9 times 2 and get 2 to the 18th power. Okay? And you can kind of, if this doesn't make sense, you can write it out the other way and see that it does work. So if I did 2 to the third 3 times, and then add these together, 3 plus 3 plus 3 would give me 2 to the ninth. Then do 2 to the ninth 2 times, so 2 to the ninth times 2 to the ninth. 9 plus 9 would be 2 to the 18th. You see, either way, I get the same solution. All right, so take a minute and try this one on your own. 4 squared, raised to the second power, and then raised to the third power. And you should have gotten 4 to the 12th. If you did 4 squared to the second power and then to the third, start on the, just like when you're doing order of operations, start at the innermost part of the parentheses. So 4 squared to the second power means I'm going to take 4 squared and multiply the 2 times 2. So 2 times 2 is 4, so 4 to the fourth. Then I raise that to the third power, so I'm going to multiply those exponents again. So 4 times 3 is 4 to the 12th. All right, and our final property for today is the power of a product. And this is just like power of a power. So when we took a power and we raised it to another power, we multiplied those exponents together. This is the same idea, except now instead of just having a single base or a single number or variable as the base, we have a product. And remember, product means multiplication. Okay, so if we take a look here, negative 2xy to the third really means negative 2 times x times y to the third. So negative 2xy to the third is a product because we're multiplying all of these things together. And we're taking this product and raising it to the fifth power. Okay. And again, what we talked about is that this can be considered the base. So this base, negative 2xy to the third, is repeating 5 times the exponent. So if I were to write this out, I would have negative 2xy to the third times negative 2xy to the third times negative 2xy to the third. And I would do this a total of 5 times. So now if I want to simplify this, what I need to do is I need to find all of the parts that I can kind of combine together. So I've got negative 2, negative 2, negative 2, negative 2, negative 2. Well, I'm multiplying negative 2 a total of 5 times. So I have negative 2 to the fifth power. If I look at the x's, I have 5 x's being multiplied, x times x times x times x times x times x, which gives me a total of x to the fifth power. And then how many y to the thirds do I have? Well, I've got 5 of those also. There's y, 1, 2, 3, 4, 5. So I've got y to the third also to the fifth power. And what you see here is this expression, negative 2 times x times y to the third raised to the fifth power. What the power of a product says is that when we write this all out as multiplication and then we combine it again with exponents, okay, each part of the product, negative 2 has a power of 5 now. X has a power of 5. Y to the third has a power of 5. If I wanted to simplify this, negative 2 to the 5th, x to the 5th, and then with y, I'm doing y to the 3rd 5 times, so that's a total of y to the 15th. So what happened here? All we had to do was take this exponent that's on the outside here, multiply it times the exponent on each part of the product. Okay, so we're multiplying 5, negative 2 to the first power, so 1 times 5 is 5. X to the first power, 1 times 5 is 5. Y to the third to the fifth power, 3 times 5 makes 15. So negative 2 to the fifth, x to the fifth, y to the 15th. And if you wanted to simplify negative 2 to the fifth, you would get negative 32, x to the fifth, y to the 15th. Okay, so with a product, we have to remember to share that exponent with the entire part of the product. Okay, what a lot of people end up doing is they forget to they'll do the variables. They'll do x to the fifth, y to the 15th, but they forget to share that 5 or whatever that power is with the power with the coefficient or the number there. So remember, when you're raising a product to a power, you need to share that power with every part of your product. All right, so if we take a look at an example of how we would use this, it says find the volume of a cube with a side length 5x, y, z. So the first thing we need to know is a cube. Right? So if we take a cube, just draw a quick sketch of a cube. Right? Each side is 5x, y, z. So every side length is 5x, y, and z. Okay, so this side is 5x, y, z, 5x, y, z, and 5x, y, z. All right, so if we want to find the volume, well, how do we find the volume? We need to do length times width times height. Or because this is a cube, all of these distances, the length, width, and height, are all the same size. So we say that's the side times the side times the side, which in this case makes that side to the third power. So the volume of a cube is just the side raised to the third power. So if we know that the side is 5x, y, z, I'm going to multiply 5x, y, z 3 times, by itself 3 times, or raise it to the third power. So now the rule that we just came up with here says we take this product, 5x, y, z, and raise it to the third power. That's like raising each part of this product to the third power. So we do 5 to the third power, x to the third power, y to the third power, and z to the third power. And if you do the multiplication, 5 to the third power means 5 times 5 times 5. Well, 5 times 5 is 25, and then 25 times 5 is 125. And then for my variables, they stay x to the third, y to the third, and z to the third. So the volume of a cube, if each side is 5x, y, z, is 125, x to the third, y to the third, z to the third. All right, so your turn. Express the surface area of the cube as a monomial, meaning find the surface area of this cube is what they're saying. Well, to find the surface area of a cube, you need to know the formula. The surface area of a cube is the area of all of the faces. Since they're all the same, you find the area of one of these, which would be s squared, and do it the number of faces that it has. Well, a cube has 6 faces, so the surface area is 6 times s squared. So using that formula and the distance and the side length over here, 2pq, calculate the surface area of this cube as a monomial. And you should have gotten b, 24p squared q squared. And again, if you want to find the surface area, you need to you do 6 times each side squared. So the side is 2pq, and we're squaring that. So our rule says that if we're taking this product, 2pq, and raising it to the second power, I'm going to put that power with each part of the product. So it becomes 2 squared, p squared, and q squared. Then it's just a matter of simplifying. So 2 squared is 4, because 2 times 2 is 4. Then I'm going to multiply 6 times 4, so I get 24 p squared q squared as my surface area. All right, so now let's take a look at one that kind of combines all of our rules together. So we've got this really complicated looking expression here. 8 g to the third h to the fourth, and that whole product is raised to the second power. Then it's raised again to the second power. And then we're multiplying it by 2 times g h to the fifth, which is being raised to the fifth power. So this can look overwhelming, but if we break it down into parts, you'll see that it's not too bad. So let's take a look at it. We can look at this as two different parts. We've got here 8 g to the third h to the fourth raised to the second power and then raised to the second power again. So that's one part. And then over here I've got 2 gh to the fifth raised to the fourth power. So if we take a look at each of these, you see it's not as bad as it looks. So we take 8 g to the third h to the fourth, and we square it. Okay? And then we're going to take that and square it again. So the first thing is to start with this first part here. We're taking 8 g to the third h to the fourth and raising it to the power of 2. So we're going to take that 2 and we need to share it with all the parts of that product there. So that's going to make this 8 squared. G we're going to multiply 3 times 2. And h we're going to multiply 4 times 2. Then the second part over here was 2gh to the fifth raised to the fourth power. We can do the same thing here. Share this with each part of the product. So it becomes 2 to the fourth. G, remember, has a power of 1, so it's 1 times 4. H has a power of 5, so we're doing 5 times 4. So now let's rewrite this by combining those exponents. So we've got 8 squared. G, if I do 3 times 2, that gives me g to the 6th. H, 4 times 2 is h to the 8th. And in the other expression, 2 to the 4th, g, 1 times 4, so that's g to the 4th. H is to the 5 times 4, so that's h to the 20th. Now let's repeat the process over on this first part of it by sharing the 2 again with all the parts of that product. So we're doing 8, we're doing 2 times 2. Oh, didn't mean to close the parentheses there. So 2 times 2. G, we're going to multiply 6 times 2. H, we're going to multiply 8 times 2. And the second part of my expression here for now is simplified. So I just write it down again. 2 to the fourth, g to the fourth, h to the 20th. So now let's combine my exponents here. So 8 to the power 2 times 2 is 4. G, if I multiply 6 times 2, gives me 12. H, 8 times 2 is 16. And then 2 to the fourth, g to the fourth, h to the 20th again. So now looking at what we did is we took the original expression here and we simplified it into two different parts. So I took 8g to the third, h to the fourth, raised it to the second power, and then raised it to the second power again, which gives me 8 to the fourth, g to the 12th, h to the 16th. And the second part, 2gh to the fifth raised to the fourth power, became 2 to the fourth, g to the fourth, h to the 20th. Now, what I want to do is look for any bases or powers that I can combine if they have the same base. So I've got a g here and a g over here. I've got an h in the first expression and an h in the second expression. And I've also got numbers. So when I rewrite this, I want to combine the numbers together first. So we're going to do 8 to the fourth times 2 to the fourth. Then I'm going to do g to the 12th times g to the fourth. And then h to the 16th times h to the 20th. 8 to the fourth power, if you do 8 times 8 times 8 times 8, you'll see that that comes out to 4,096. And 2 to the 4th power means 2 times 2 times 2 times 2, so that's 16. Now, when I want to combine these two g's, because they have the same base, I'm multiplying powers with the same base, what am I going to do with the exponents? I'm going to add them together, so 12 plus 4. Same thing with the h's. The bases are the same, so I add 16 plus 20. So my final answer, when I multiply 4,096 times 16, I get 65,536. And G, when I add 12 and 4, I get to the 16th power. H, I add 16 and 20, I get to the 36th power. So taking that original expression there and simplifying it all the way down gives me an answer of 65,000, G to the 16th, H to the 36th. All right, so it's your turn to try one of these tricky ones. Use all of the different power rules that we have for adding, multiplying powers with the same base, raising a power to a power, or raising a product to a power, and go ahead and simplify this expression here, and then we'll go over how you get the solution. So you should have gotten a correct answer of 1,728 times c to the 27th times d to the 24th. And again, what you could do is you can take this into two different parts. Simplify the first part, simplify the second part, and then combine the two together. So if you take 2c squared d to the third and raise it to the second power, the first thing that you're going to do is do 2 to the second, c, we're going to multiply 2 times 2, d, we're going to multiply 3 times 2. And then once we simplify that, we're going to raise it again to the third power. In the second part, we're going to do 3 to the third, c, we're going to do 5 times 3, and d is 2 times 3. So when we simplify all that down, I've got 2 squared. I'm just going to simplify that now, so that's 4. C is to the 4th power, d to the 6th power. Raise that again to the third power. 3 to the third means 3 times 3 times 3, so that's 27. C is to the 15th, and d is to the 6th. So now we're going to take this product here, 4c to the 4th, d to the 6th, and raise it to the third power. So we're going to multiply each part of the product, raise it to the third power. So it goes 4 to the third power. C, we're going to multiply 4 times 3. And d, we're going to multiply 6 times 3. 27, c to the 15th, d to the 6th. And so 4 to the third power, I know 4 times 4 is 16. 16 times 4 is 64. C, if I multiply 4 times 3, it's 12. D, 6 times 3 is 18. And multiply by 27, c to the 15th, d to the 6th. So now I just want to combine the numbers and then combine any variables that have the same bases. So I'm going to multiply 64 times 27. And when I do c to the 12th times c to the 15th, and d to the 18th times d to the 6th. So 64 times 27, right away I can see that the only possible reasonable answer here is 1,728. And then for the c's, I'm going to add together 12 and 15. For the d's, we're going to add together 18 and 6. So my final answer is 1,728. C is to the 27th power, D is to the 24th power, which as you can see is answer A. All right, so just a quick review of everything we talked about, the three properties that we went through. The product of powers, if you're multiplying powers with the same base, add the exponents. If you're raising a power to another power, you multiply the exponents because you're repeating that power that many times. So b to the third raised to the 5th power is b to the third 5 times. So 3 times 5 is 15. And then the last one, power of a product. Make sure if you have a product like this here, negative 2xy to the third, raised to a power, you have to raise each part of the product to that power. So negative 2 to the fifth, x to the fifth, y to the third, 5 times is y to the 15th power.